Hello everyone, topic is mechanism of Dow's process. Yesterday we have covered this process for the generation of phenol from chlorobenzene. Mechanism was not involved because it was for the 12th class, and in 12th class mechanism of Dow's process is not in the syllabus. But for JEE, NEET and B.Sc, very important topic. Let's first recall what reaction it was. In this reaction, one molecule of chlorobenzene at 623 Kelvin temperature, 300 to 350 atmospheric pressure was reacting with two particles of NaOH, aqua, generating sodium phenoxide. Side product was sodium chloride and water molecule. This sodium phenoxide on further acidification, means reacting with acid, was giving phenol and sodium chloride as a side product. This phenol was our main product. So this was the reaction, and yesterday I have told you a trick to learn it up to 12th level, but mechanism was not discussed. Let's start the mechanism now. Before start of the mechanism, you should know what we call this mechanism. We can call it elimination addition mechanism, because the very first step elimination will happen and next step addition will happen. So we can call this mechanism elimination addition mechanism. Secondly, we can call it benzene mechanism, because intermediate will generate there, that will be benzene. What is benzene? Benzene we know, a 6-carbon cyclic compound containing sigma bond and pi bond, alternate positions. So this is benzene, very well known to us. But if between any two carbon triple bond is generated like this, so it will become benzene. This intermediate will be generated in this mechanism. That's why we can call it mechanism of benzene or benzene mechanism also. Let's check. The very first step involve elimination reaction. Chlorobenzene. In chlorobenzene, as you know, between chlorine and carbon, sigma electrons are there. Covalent bond is there. And chlorine is more electronegative than carbon. So obviously, these electrons are more toward chlorine side. That's why chlorine is getting partial negative and this carbon is getting partial positive. When we apply a very high temperature, this bond will break. And whenever this bond will break, obviously electrons will completely transfer toward chlorine. Due to which, as this bond will break, there is a generation of carbocation. A positively charged carbon will start generating over here. At that time, at the same time, the neighboring carbon, this carbon, because here there is a development of a vacant orbital because chlorine is going out with these electrons. So on this carbon, vacant orbital will start to generate. At the same time, this carbon will start to fill that vacant orbital like this. So from here, number one, Cl with 4 pairs of electron will out there. 3 already it have. Fourth will come from this side, and in this fourth pair, 1 electron was of carbon. So it is getting 1 extra electron, so -1 charge. And this hydrogen, it is losing its electron because this electron is going to that side for the satisfaction of a vacant orbital. So this H will release out as H positive. Now HCl means an acid. NaOH we are using. NaOH is a base. As you know, in aqua solution, Na positive, OH negative will be there. So Na positive is going to neutralize this Cl negative. So NaCl and OH negative will attack on this H positive, so H2O. So side products will be NaCl and H2O, and one particle of NaOH is utilized. What about this? It will turns to this. When these electrons will shift here, vacant orbital is there, bond will generate this one. Other hydrogens are as it is, no change in them. Here also we have a hydrogen, here also hydrogens are there, as we know about benzene ring. This will generate. This already I have told to you, this is what? This is benzene. This is a benzene intermediate. Now further reaction will be processed by benzene. Now one question will arise in our mind, why we are using this side hydrogen, not this hydrogen? Because vacant orbital is there, it can be also satisfied by this carbon like this. Okay, let's check what will happen if I am using this carbon. When this carbon will be utilized, you can check between this carbon and this carbon double bond will generate, and condition will be something like this. Continuous 3 pi electrons will be there, 3 pi bonds, first pi bond, second pi bond, third pi bond, and they are in a strained condition, means you can check it's an angular molecule. It's not a linear, it's an angular molecule with continuous pi electrons. So a lot of repulsion will generate. That's why this molecule which I have generated, it is highly unstable. Benzene is better than that. That's why this path is not followed by the reaction. Means this hydrogen will not be utilized. This hydrogen will be utilized. Now you can check it's an elimination reaction. In 11th class we have done what is the meaning of elimination reaction. 2 atoms or 2 groups are eliminated out. You can check Cl is eliminated out, H is eliminated out, 2 atoms are eliminated out. Such reactions are known as elimination reaction. So this is an elimination process. Now next step. Second step, addition. Now who will be added? Let's check. The intermediate was generated over here. First we need to understand the feature of this intermediate. These carbons, these all 6 carbons are sp2 hybridized. These all 6 carbons are sp2 hybridized. Okay, sp2 hybridized, these carbons, this carbon, this carbon, this carbon, and this carbon, they all are normal carbons. Problem will be there in these 2 carbons. Now what is the problem? Let's check. For this, I need to start it from its initial condition. This was the initial condition. This carbon was sp2 hybridized. This carbon was also sp2 hybridized. This one. When chlorine left this orbital, so these 2 electrons were gone with chlorine, due to which here we have a vacant orbital. And this carbon has broken bond from hydrogen and got both electrons in its orbital. So here we will have a generation of this orbital with 2 electrons in it. Now the problem is hybridization is sp2, and we know in sp2 the shape of the orbital is triangular around carbon. This is the carbon, so triangular orbitals will generate. This is the orbital, this is second orbital, this is third orbital. Angle between them will remains 120 degree. Same case is here. This carbon, this orbital full of electron, this orbital, this orbital. With these orbitals, it is making sigma bonds overlapping. Angle again 120 degree. So the direction of these two orbitals are quite away from each other. This orbital is going to that direction. This orbital is going to that direction. Due to which, if they will overlap for the bond formation, the ring will come in strain. Strain means you are forcefully overlapping them like this. Even they will overlap, but the condition will be proper overlapping will not be there. If in a simple language I will say that proper overlapping will not be there. Proper overlapping means for sidewise overlapping, this will be a sidewise overlapping. One is head-to-head overlapping, one is sidewise overlapping. This will be a sidewise overlapping. But for proper sidewise overlapping, the orbitals which are overlapping must be parallel to each other like this. It is proper overlapping. But here you can watch, this orbital is going in that direction, this orbital is going in that direction. So proper overlapping will not be there. Means they will share electron, but that sharing will not perfect. The molecule will be highly strained because forcefully they are overlapping with each other. So obviously this forcefully overlapping will make strain in a ring, will make this ring highly unstable. Now because the overlapping is not perfect, overlapping is not perfect, due to which these orbitals, both orbitals, will not have sufficient filling of electron. In simple language, we will try to understand the concept. Because if they will not overlap properly, like if we have a proper overlapping, like this, so two electrons will come here in a overlapped area. So we will say the orbitals have sufficient amount of electrons in them, properly overlapped. But because these orbitals are going in different directions, so when they will overlap, these orbitals will not have sufficient filling of electrons in them. That's why these orbitals have tendency to gain electrons. Due to poor overlapping, these orbitals are not sufficiently sharing, or you can say they do not have sufficient filling of electrons in them. So these orbitals have a deficiency of electron. That's why these orbitals have a tendency to gain extra electrons. So they are working as, these carbons are working as electrophiles. Such condition is not in any other carbon. This carbon, they are properly overlapping each other orbitals, pi bond perpendicular and this sigma bond in a plane of the molecule. But here between these two carbon, here we have this problem, due to which these orbitals do not have sufficient filling of electron. If sufficient filling of electron is not there, so every time they are ready to get extra electrons in them, means they can work like an electrophile. Now the point is, who can provide electrons to it? Let's check. Now I am making a normal condition of it. We have understood the concept. Now these carbons are electron deficient. Who can provide electrons to them? Sodium hydroxide aqua will break in two parts, Na positive, OH negative. This one. In OH negative, you can check oxygen have 3 lone pairs. That's it. These carbons require electrons. Oxygen of OH have extra electrons. So don't you think this OH is working as a nucleophile? And these carbons are working as an electrophile. Electrophiles are looking for electron. Nucleophiles are looking for vacant orbitals. They have vacant orbitals because in their overlapped orbitals, sufficient filling of electron is not there. So any carbon it can attack. Suppose I am attacking this carbon. For bond formation, 2 electrons are required. This oxygen is coming with those 2 electrons. So obviously these pi electrons will be shifted to the next carbon like this. This bond which was generated, it is highly unstable bond, weak bond, because overlapping was not proper. So OH is attacking on this, pi electrons will shift to next, due to which we will get this condition. This oxygen will make dative bond with this carbon. In this bond, 1 electron, it will completely transfer toward carbon. So its negative charge will finish, it will become neutral. And here this carbon will get this pair of electron back on it, making itself carbanion. Now how this carbanion will be stabilized? Condition is aqua, means water molecules are there. In water molecule, as we know, H positive, OH negative ions are available. This H positive is an electrophile, vacant orbital always it have, so it will attack on it. Firstly, we will get this H, phenol particle. So you can check in this step, OH means nucleophile is added here and H positive means electrophile is added here. Any reaction in which nucleophile and electrophiles are added on a same molecule are known as addition reactions. So this step is addition step. First step was elimination, second is addition. Now phenol is generated, but wait, this phenol will not be available to you in this form. The problem is the phenol generated here is acidic. Let's check what will happen. Third step, let's write. So after elimination and addition, we got phenol, but the problem is in phenol, the hydrogen is connected with oxygen and oxygen is highly electronegative. It is attracting electrons toward itself. That's why this hydrogen is getting positive charge, means it is becoming acidic hydrogen. Now conditions are basic. Na positive, OH negative. This OH negative will attack on this acidic hydrogen, acid-base reaction simply. H2O will release out. And this Na positive, when the bond between oxygen and hydrogen will break, electrons will completely transfer toward oxygen and oxygen will become O negative, which will be satisfied by Na positive. Between oxygen and sodium, there will be an ionic bond, and this compound which is generated over here is known as sodium phenoxide. Side product is H2O. This one. Now this sodium phenoxide will be acidified further. How? Let's check. Very simple reaction. Acidified means we have to react it with dilute HCl. That HCl we know is an acid. How it will break? Chlorine is more electronegative than hydrogen, so bond will break like this. Hydrogen will release out H positive, Cl as a negative because it is getting extra electron of hydrogen. 3 pairs you can draw around it. In this condition, it will have 4 now because extra pair is generated over here. This H positive will attack on oxygen negative. This Cl negative will attack on Na positive. So finally, oxygen will have its hydrogen. Oxygen will use its lone pair to make a dative bond with hydrogen because it was getting one extra electron on oxygen. That's why it is carrying -1 charge. Now this electron it has delivered to hydrogen, so its charge will finish. And H do not have electron, that's why it is carrying +1 charge. But after getting one extra electron from oxygen, it will also become stable. So phenol is generated and side product will be NaCl, sodium chloride salt will be generated. So this is the whole mechanism we have for Dawes process. That's it. This is the end of the video. Please check whole mechanism. Every point try to understand in brief. Thank you very much. In next video, we will understand next preparation method of phenol.